So I heard there's a rumor that class is canceled today because of voting. Was that going around?
Yeah, today is
Today's some voting today, so somebody. Yeah, no, it's not. But there's a rumor going around.
I mean, if it is.
One of the students from this class asked me last night, "Hey, is class canceled because of voting tomorrow?" And I was like, "I don't think so." So I said, "I'm going to be here."
They're not here. They're probably not even voting.
Yeah, probably. Yeah, right.
They're just not communicating.
Yeah. All right, well, we're getting close here. Yeah, it's 11. So let's do it. So last class, I did not record last class because I said all we're going to do at the very end is have a very simple formula. And I gave you a couple of problems to try for homework. How did those work out? No problems? Those are pretty straightforward, yes? So what we're going to do now is we're going to transition using the same idea. I'm going to ask a question. I think I did pose this last class, but I want to repose the question. And we're going to see that we're not going to be able to figure it out. So you plan to put, let's say, $10,000 into an account at, let's go with 3.5% interest. How long until you have, all right, I'll let you decide. So you're going to put $10,000 into an account. You're going to let it sit there and you're going to let your money grow because the bank's going to pay you to have your money. 3.5% interest is what they're going to pay you. And now the question is, how long do you need to leave that money in there in order for it to grow and become how much? How much do y'all want? $1 million? Well, you'll be dead. 20,000, double it? Let's double it. Okay, till you have 20,000. Right? That's the question. So we can still use this formula, simple interest. Let's fill things out. So what is the 10,000 for us here? The P, the principal, the amount that we start with. Okay, what is the 3.5%? That's our R, but remember we'll have to convert it to a decimal, right?
Yeah.
And then the 20,000. That's the A, that's the amount that we want at the end, right? What do we not have? We don't have T, but that's what we're asking, right? How long? How long? So let's put this on the board. I'm going to write the equation up there. 20,000, that's A, okay, from that equation, equals 10,000. And then E to the R, which is 0.035 times T, right? Like that. Now, on your homework problems, you had P, you had R, and you had T, didn't you? Yeah. And you just plugged it all into your calculator, and then you got this answer. What we're trying to figure out is what does T need to be in order for this whole thing to come out to be 20,000. That's a much different question and a much more challenging question because it's not just a calculator question at this point. It eventually will become just a calculator problem. But right now, we don't know how to do this. Do y'all see that? Now, one thing we could do, all right, I will stress again, we are solving for this, right? We're solving for this, but, you got it? Thank you. Solving for this, but it isn't something easy, right? It isn't something easy because we've never had a problem before, in this class at least, where the variable we're solving for is up in the exponent, right? So we are stuck at this point. We are stuck. We could do this though, all right? We could do this. We could divide both sides by 10,000. That would be a legal move because that's multiplication between here. So you could get rid of that 10,000 and then the left side becomes, I got it. I need to just retire from this. All right. Yeah, I was just going to say, I'm just going to move this here. So what is the left side? Division. Right. 2. Right, you just get 2.
Oh, you just cross out
Yeah, the zeros go away. And then on this side you have e to the 0.035t. That step we could do. But at this point, we're stuck. All right? So how do we solve this, right? How do we solve it? That's what today is about. And then we'll come back to this and we'll solve it. All right? So we're going to take a pause here. We're going to introduce a new concept. And it's not going to be, I'm not giving you the full-blown treatment of this. All we're going to do is just enough. I'll leave that. I'll get rid of it. We're going to do just enough for you to be able to use your calculator to solve the problem. All right? So everyone have their calculators? Okay, I'm gonna show you how this works, all right? So let's try, that equation we can't figure out, right? Let's try something else. If I told you you take 2 and raise it to the t and you get 8, can you just look at that and tell me what t would have to be?
3.
3, right? Because 2 to the 3rd power, right? Do you agree? 2 to the 3rd power. All right. When we see an expression like that, we are allowed to convert it to a different expression, right? This is what's known as an exponential equation, right? I'm going to put that here. This is called an exponential equation. Keep in mind, eventually we want to solve this, right? Eventually. But I'm starting out with something easier because we can look at this one and just tell that the answer is 3, right? So once I do all this work and I get to the answer 3, it'll make sense to you that we got the right answer. So this is called an exponential equation. In order to solve these, right? To solve these, we need what are called logarithms. And I really don't want us to get lost into what logarithms are here in this class. I really don't want us to. But we have to go a little bit deep. I mean, we're going to go deep into it, but just enough. Just enough. So let's get rid of this. Please remember that because I'll be asking for that later. Yeah, you have to understand the notation. This is the thing that confuses students is notation. So look. If I write this down, I'm going to go ahead and put this logarithm. Let's talk about logarithms. What are they? Well, here's what a logarithm is. If I write down this, just write it down, then we'll talk about it. Okay, just write that down. And I know when you see that first time, you're like, what the hell is this? This is a new expression. Log, okay, stands for logarithm. This a right here is what we call a subscript, right? It's written down below a little bit. So you have log subscript a, and then you have x, and then equals y. And so you're looking at that, you're like, what the hell does this mean, right? What does that mean? Here's what this means. This means that a raised to the y equals x. These two statements are equivalent statements. If I say you take something a and raise it to the y, and that equals x, then another way I could write that is like this. So let me show you a specific example next to this. As an example, if I write log, and then I write 3, 8, let's go 9. equals 2, like that. Okay, let's see, what does this mean? This means, what's A for us here? 3. Okay, raised to the y, what's y for us here? 2 equals the x here is the 9. Do y'all believe that that's true?
Yes.
It's just, this is just another way of writing this. That's all it is. It's just different notation. So instead of writing this, I can write this. Okay? So what I like to teach my students is that if you're trying to go from here to here, you can use this thing, which I call the loop. The loop. And the loop goes like this. You start at A. You say A raised to this must equal this. You all see that little loop I made? This little loop? A raised to the y equals x. A raised to the y equals x. A raised to the y equals x. That's how you go from here to here. All right, now, with that idea, will you help me please rewrite this?
So 2 to the 8.
Careful, we're given this, aren't we? Okay, so for us, the A is what? 2. The Y is? The Y is T, and the X is 8. So we want to write that in this form as a logarithm. So you go log, what's the subscript? 2, and then 8, and then equals T. Okay, all that is rewriting that in a different form. So this equation that we couldn't solve turns into this expression. Right? Any questions? It's just rewriting, right? So all a logarithm is just another way to write something. Now what we need to do is figure out what this is. Right? We need to figure out. Now we know the answer is what?
3.
We know the answer is 3, right? We know that this should be 3. We know that this should be 3. But how? Right? How? So we're going to need our calculator to do something like this. Now, everyone have their calculators? Yes? So somehow, this is going to become 3, but how? But how? Well, we need one more thing. On your calculators, I want to leave that up there. On your calculator, all of you are going to have a key that looks like that. Now, you may also have a key that looks like this, LOG. Some of you may or may not have this. Everybody has this on their calculator. Do you all see your key? Okay. This right here these are both logarithm keys, and it helps you solve these problems. This one is called the base 10 logarithm, not important. This is called the natural logarithm. We are going to use this key to solve this problem. But to use this key, we have to have one more formula. Do you not see it?
I see both.
Yeah, that's okay if you have both.
So
I'm saying you may have this one, you may have that one, you may have both, but all calculators should have this one.
Gotcha.
So what we're going to do is we're going to look at this one, all right? We can ignore this one. And last formula that we need, this is it right here, is this. If you ever see log base A of x by itself, just like this, this is equal to natural log of x over natural log of A. This is referred to as the change of base formula, not important again. That formula is what we need. Remember, I'm not trying to get you to understand all this. I'm trying to get you just get to the point where you can just go to your calculator and solve this problem, right? So let's recap. We start with this equation. We know the answer is 3, but how do we get there? First, we rewrite it using the logarithm notation. Then, do you see this side right here? Do you see this looks like this right here? Right there. Right? What's in this formula, what's A for us here? 2, and what's X? 8. So this is what I need to do on my calculator. On this left side, This left side is going to turn into natural log of 8, or I'm going to say natural log, that's what it stands for. Natural log of 8 over natural log of 2 equals t. And you have to type this into your calculator. And be careful, because when you type it in, you have to type the key natural log. Most likely you'll type it like this. Natural log, you'll do 8, then you have to have the division key, natural log, and then 2. And go ahead, what do you get? Well, did you get 3?
No, I got 2.44.
Oh, I see what you did. Okay, so you need to close the parenthesis around the 8. Close the parenthesis. Yeah, everyone's calculator is going to be a little bit different. Natural log, close it around the 8, divide, natural log, close it around the 2. You got it? You got 3. Good. Now you might get 2.9999999, depending on your calculator. You might get 3.0000001. And that's just because there might be a little rounding error on the calculator. You got 3. Okay? That's it. Again, that gave you just keystrokes. We get to an answer. Let's do another one. Before we get to the problem that we stopped with a second ago, with the money. So try and solve this. Solve 4 to the x equals 10. Now, for this problem right here, I do not know what the answer is, okay? Like this one, I knew the answer was 3, right? But this one, I actually don't know the answer. So what am I going to do first? Do this to here, right? Do this to this. So turn that in this. So I'm going to write log. What do I put in the subscript? The 4, right? The a is the 4. Then what? The x is the 10. And then equals what? X. And now you use this formula, right? And you switch it. You got an answer already? Okay, you get natural log 10 divided by natural log 4. And then you do that on your calculator, and you got x was what?
1.66.
1.666?
1.6609.
Oh, no. Okay, I thought it was 666. Thought that'd be fun. All right, so approximately 1.66. Right? There you go. So now let's check the answer. Let's just check it. I just want you to take the number 4 and raise it to the 1.66. Remember last class we did raised, right? So do 4 raised to the 1.66. And you should get something close to 10.
9.9.
Yeah, 9.9. There's a little bit of error there because we rounded this number. What do y'all think? It's a way to get the answer, right? That's all we need is a way to get the answer. So let's return. Y'all want to return? Yeah, let's return to the word problem. Where we had stopped, we had 2 equals e to the 0.035t, right? That's what we had? And we were trying to figure out, we were trying to turn that $10,000 into $20,000 at 3.5%. And we're trying to solve for t. So do y'all see that we have this right here? Yeah. Do y'all see we have it? Hey. This right here is this, right? All of that. And then we have what? The a for us is actually what? E. And then the x for us here is the 2. And then you're going to switch everything over using this formula going from here to here. So we'll always start with the log. Now, start with the log. Okay, what is the number that goes on the bottom here? E. And then what comes next? 2. And then equals 0.035t. 0.035t. Y'all see that's this right here converted. Any questions on the conversion? Now, this right here, we are supposed to use this formula, right? But you can use the formula, but I will tell you something. If you ever see this with an E down here, if you ever see that, then this is just simply, they don't cancel out. It just, that's what the natural log is. So this just becomes natural log of 2. Instead of doing this, natural log of 2 over natural log of E, that's what you would have to do if you use that formula. Natural log of 2, natural log of E. Then this winds up, the thing is the bottom is 1. So you either do this on your calculator or you just use the fact that this, I'm telling you that that's natural log of 2. What do y'all get? Did anyone do it yet? Either do natural log of 2 or do natural log of 2 over natural log of E. Remember the E key? We looked at that last time. Y'all have your E key there? Who has an answer?
I do.
What do you have?
0.693.
0.693. Anyone else have that? Yes? So this side becomes so left side becomes 0.693 equals, now we still have this here, don't we? 0.035t. Who has a question? Anybody have a question on how we got this decimal?
I don't.
Okay, so you're trying to do this, right? So I'm telling you, you can either do it this way on your calculator, type it in like this. I'm using that formula right there. Or anytime you see an E down here, you can just ignore that formula and just turn it into the natural log of 2. Your choice.
So would it be 2 over 2?
2 over 2. Do you want to do this one or this one? You want to do this one? Okay, then I just need to see you type it in.
Would
So-
it be like that?
You did 2 twice. This is an E.
Oh, you. That's okay. I just.
Do you see what I'm saying?
E over 2.
Okay. Divided by natural log. Now you have to put E in there. Just put 1 for that power. Yeah.
No.
Close it. There you go. Anybody else need help getting this side? We're okay? Everyone good? Yes? Okay, now solve for t. What do you do to solve for t? Divide both sides by 0.035. Divide by 0.035. You're going to get a pretty big number. What is it? No?
19.80.
19? Anyone else? 19? 19.8? Somewhere around there? Approximately is T. So we had $10,000. We put into a bank at 3.5% interest. We want to know how long it was going to take to basically double our money. And it is 19.8 years. Because in this formula, time is measured in years. So it's going to take almost 20 years to double your money if you just put it in the bank at 3.5%. And by that time, with inflation, it'll be worth less than it was when you put it in, probably. All right. So let me give you one. All right? Let me give you another problem. See if you can figure this out. So how about this? I plan to turn $5,000 into $7,000 in 2 years. What interest rate will I need? So this problem is different than the one we just did, right? The previous one, I said, hey, $10,000, interest rate's 3.5%. Let's see how long it takes to turn it into $20,000. Now I'm saying you got $5,000. I want to turn it into $7,000. I want to do it in 2 years. What sort of interest rate am I going to need for that to happen? Okay. Do you feel like you have an idea of what you need to do? No? I'll work through this one more example, and then I'm going to let you all do one, okay? All right, so I'm going to use my formula. A equals PE to the RT, right? I'm given the 5,000. What's that? What we start with, right? P. I'm given 7,000. It's the amount we want at the end. I'm given the 2 years. That's T, right? I'm given A, P, and T. What I don't have is R, right? I don't have R. But R is up in an exponent, isn't it? So we should be able to solve for it using this idea of logarithms. Let's fill things out. 7,000 equals 5,000. E to the R times T. T was 2, right? 2 times R is 2R. See, I'm trying to solve for R right there. Trying to solve for that. Yes?
I'm just curious on the previous question.
Yep.
I am E is always a 1.
E is... Yes, so the natural log of E is always 1. Exactly.
When I see that, I just put 1 basically.
You don't have to use your calculator. You could just say that this is 1 if you want. You can just say that that's 1. And that has to do with the fact that natural log is the inverse of E, but we're not, again, this class we're not getting deep into like inverses, and we're just trying to get them like the keys on the calculator so we can solve the problem without all the theory behind it.
So I put I am 2
Yes, or just put, and it's ln, just, I don't want to say, it looks like an I, but it's French. You know how the French reverse things? This is called the natural log, and so they say log natural, logarithm natural. So it's actually ln. So you put ln2 over 1, which is just ln2. Is that answering your question? Okay. All right. Y'all good with this? Filling out the formula. Now, before you start using the conversion, there's one more step you have to do. What is it? Divide the 5,000 out on both sides. Must do that step first. They go away. Okay, the left side, 7,000 divided by 5,000, 1.4 equals E to the 2R. Again, we're just replacing everything in our formula with the numbers. Then divide by 5,000, you get 1.4 on the left. And now you should be able to come in and rewrite this with the logarithm. Now, I've erased the formula from the board, so let's see if you can do it. It's log what base? What is the subscript here? E. And then, careful. What is it for us here? What? 1.4 equals 2R. 2R. Now, you know how I mentioned the loop? You can always use the loop to check that you did it right. E raised to this should equal this. If I did E raised to this, I should equal that. Is that what that says? E raised to this should equal 1.4. E raised to 2R is 1.4. So this is correct. Now, this is, again, the special case, isn't it? Where when you see an E here, you could just not do the fraction. You could just go right to it. Just do natural log 1.4. Or you could do natural log 1.4 over natural log of E. Either way, that should give you your 2R. So what are y'all doing? You're the ones with the calculators. Are y'all doing this or are y'all doing this? First one or second one?
First one.
First one? That's the easier one. You can only do this if it's an E here. If it's something else, you can't do this. Okay? If it's E, you just go straight to this. So what is the natural log of 1.4 on your calculator? 0.336. Is that what you said? Okay. And then equals 2r, right?
Yeah.
And then divide both sides now by 2. Divide both sides by 2. And you should get 0.16 something, 8, something like that, equals r. And that's your answer almost. What am I missing here? What are we being asked to solve for?
You have to move the decimal.
Yeah, the interest rate, right? So we want to convert this rate from a decimal back to a percentage. So what is this as a percentage? 16.8% is what I would need for my interest rate, which is like credit card interest rate. That's probably not going to happen, right? Do y'all know what the average return is in the stock market over the last so many, like 50, 60 years? About 12%. So this is even higher than that. All right, well, y'all either look lost or bored. So y'all ready to do an example and make sure you know how to do it? I'll give you one. If you can figure it out, then I think you're good and we're ready to move on. Okay? So try this. Let's do this. You invest let's go $20,000 at 2.4% interest rate. So you can put some money into a bank, $20,000, 2.4%. How long until you have $27,500? All right, try that. I'm going to let you work